Alright, we're going to look at a fence problem. We're going to be using quadratics to solve this problem. So here's what it says. A homeowner has just enough money to purchase 200 feet of fencing for his backyard. Okay, he wants to use this 200 feet to enclose the greatest possible area. So first of all, as you read this, you should notice that we have a number here that represents the perimeter of his backyard. And this here shape is going to represent his backyard. It says draw a picture of the enclosure and label the dimensions. It says if you let the shorter side the width equal x. So we're going to let this equal x. And now we got to find the length. So we know that the perimeter is 200. And we know that the formula for perimeter is twice the length plus twice the width. And we want to find out what the length is. So we're going to go ahead and substitute in the 200. And we're going to go ahead and substitute in the x for the width. And we're going to go ahead and solve for L. That's going to give us our length. So subtract the 2x on both sides. So we have 200 minus 2x equals 2L. Divide both sides by 2. We find out that the length is going to be 100 minus x. And they're going to be the same. Okay, number 2, express the area of the enclosure as a function of the width. So we're going to remember to find the area of a rectangle, its length times width. So we know that the length is 100 minus x, and we know the width is x. So the area of the enclosure in terms of x is this times this. Next thing we're going to do is we're going to enter the function into the graphing calculator and sketch a picture of the function in an appropriate viewing window. Okay, so let's plug in our function. So remember, this format is the same as y, and we're going to plug in our function. Okay, and we need to make a table for make a window for this, but let's see what it looks like on a standard window right now. You can't see much, can we? So we're going to need to set up a window that fits for this situation. And our x minimum, well, x represents the side length, so obviously it can't be negative. Okay, and there's 200 feet of fencing. So for right now, one side is not going to be 200 feet long, but I'm going to go ahead and use 200 as my maximum. And I'm going to go ahead and count by tens. Y. Okay, so y is going to represent the area of this. Okay, and so if it was a perfect square, it would be something times itself that would give us 200. So that would be like the square root of 200, which is like 17. So let's just go ahead with an area of 0, can't be negative, and let's just go to 20 to see what happens. Looks like we're going to need to go a little bit higher. Notice it goes up on the graph. So let's increase our area even higher. Let's go to 200. Okay, let's keep going. Seems like I need to go really high. Ah, and there we go. You see how I'm tweaking my window? Looks like I'll go a little bit higher than that. Oh, what did I do wrong? Ah. There we go. There's a nice window. So let's just go ahead and draw ourselves a little sketch of this. Okay. And we're looking for, let's put our window information in over here that we chose. Ooh, I went by ones. That's probably not a good thing to do. I'm going to go by hundreds. See how that changes my graph. Yeah. Okay. It says find the maximum area of the enclosure. So the maximum area of the enclosure is going to be found at the vertex. Okay. So second calc, it's a maximum. And we're going to go ahead and go to the left, and then to the right, and then enter. So our maximum area, remember y represents area, is going to be 2,500 square feet. Okay? And then it says what are the dimensions that will give you that area? Okay, well, we know that x, remember x represents the width. So we know that the width is 50. Okay, so we know the width is 50. And then we're just to find the length. It's going to be 100 minus x. Remember that? We calculated that up here. So the length is going to be 100 minus 50. So the length is going to be 50. So his backyard, the fencing, to get the maximum area of 2,500 square feet, you're going to need a 50-foot by 50-foot fencing. Oops. All right, let's keep moving on. Let's see what we got next. All right, the homeowner could enclose even more area if he used the back of his house as one side of the enclosure. So here's the back of his house. So that's going to, you know, he's not going to need fencing for this portion right here. Okay, so let's take a look at what would we do here. So we have our picture drawn for us. Okay, we're going to go ahead and use a width of x again. Okay, and we're going to use our little formula again to find our length. So we have 2L plus 2W for perimeter. So we know that the perimeter was 200 feet. Okay, we're looking for L. And we know the width is X. So we're looking for the length. So solving for L. Alrighty, and oh, made one little mistake. We don't have two lengths, do we? We only have one length. So we have two widths, which is this portion right here, and we only have one length that we have to account for. So we don't need a 2 on the L. Okay? Because remember, the house is going to take up one side of the enclosure. So we've solved for L. So this side's going to be 200 minus 2x. Alright, write an equation for the new area. So again, we do length times width. So we have 200 minus 2x times the width. That's going to be our area. let's go ahead and plug it in. 200 minus 2x times x. Alright, let's see what our window gives us. Okay, so we need to increase our y max. Let's go up to 5,000. Oh, I always do that. Okay. Alright, we can see the whole thing now. So again, without going into too many details here on our sketch, we could get more detailed. But again, we're going to have, okay, and the window, you can plug that in. Pause your video and plug that in. I'm running out of time, so you can put that in yourself. Alright, what is the maximum amount of area? So remember, the maximum is found at the vertex. So again, we're going to find the vertex. Let's see. Alright, so we have a maximum area of 5,000 square feet. And our dimensions, so that's going to be, our width is going to be 50. And then our length is 200 minus 2 times 50. So that's going to be a length of 100 feet. So the dimensions are going to be 50 by 100 feet. All right. Let's see, I think I'm running out of time here. This is a new problem that we will not go into right now. We'll use these as more examples if we need them in the future. So tomorrow I'll be checking your video notes and we'll be working on some applications of fencing. Hope you guys are having a good night, and this is a shout out for Tion, not Isaiah. Tion.